Hello, today I wanted to talk a little bit about some common misconceptions within physics. I'm a graduate student at North Carolina State University, and I enjoy educating people about physics so that we can learn more about physics together. One of the most common misconceptions about physics is the misconception that mass and weight are the same thing. In fact, they are not. Weight is the created by the pull on a object by the force of gravity, which is created from mass being on something else. The mass of an object warps space-time, which creates a gravitational field. And when two objects that have mass become close enough for their gravitational fields to interact, there is a gravitational force created. The next misconception about physics I wanted to talk about is that physics is just something that people within an academic setting find useful. This is indeed not the case. Physics is all around us in our everyday life, from designing the car to get us from point A to point B during our morning commute, to the forces that interact with our shoes as we walk around our city on a daily basis. Physics, I think, is useful for everyone without exception. I think that when learning physics will provide interesting insight and useful insights for everyone, no matter if they're in an academic setting, if they're an engineer, or if they are in the service industry. No matter what, I think that studying physics is a worthwhile and interesting endeavor for anyone. The third misconception that I wanted to talk about is that to understand physics qualitatively requires a strong background in mathematics. And while it is true to go and study physics in a very rigorous way, math is frequently necessary, from calculus, differential equations, probability, linear algebra, and above. But to understand the basics of physics at a qualitative level, oftentimes high school math is enough. Although if you do have the opportunity and the ambition to study mathematics at a higher level, to understand the quantitative applications of physics, I highly encourage you to do so. Learning physics using calculus and differential equations will provide much more insight than studying it at a purely qualitative level. And finally, some next steps and advice to people that want to expand on their physics knowledge. There's many useful and very good tutorials, classes, lectures, and other resources online to expand on your physics knowledge, no matter where you are in your physics journey. Whether you're a beginner, if you studied physics at the high school level or at the university level, I encourage you to take advantage of these resources. But if you want to expand on your physics knowledge professionally, I would encourage you to look into either an undergraduate program if you haven't completed a bachelor's degree yet, or if you are a little bit more advanced, if you have a bachelor's degree in a STEM field and your mathematics background and science background are strong, then I encourage you to look into some graduate programs within physics if you want to do physics professionally. I come from an electrical engineering background, and I went back to complete my PhD in physics, and I found it extremely rewarding. So I'd encourage any of you who are interested and motivated to do so to look into it farther. And that's about it. Please like and subscribe for more interesting physics content.